Hello. This time I'm going to explain chapter 8 material from our algebra textbook, which is about the quadratic function. I'm going to use the handout during for the winter break assignment to explain. So the handout have about 40 problems. The first one have 4 questions. So here you go. So answer the following problem. Number 1. Expand and write in a standard form of a polynomial. Okay, so the standard form means you are going to write in the expanded and in descending order like this. So for example, number 1a, this is like a quadratic expression, but it in the factored form. We are going to expand this one by using a distribution. So this is gonna be like using a FOIL, like this times this times this, and this times this, and this times this. So it's gonna be like x squared plus 4x, that's upper 2, and negative 2 times x, and negative 2 times 4. So it's gonna be x squared plus 2x minus 8. So the order of degree is 2, 1, 0. For the quadratic expressions, standard form means ax squared plus bx plus c. Okay, that's what we want to obtain at the end. Part B, x plus 3 times x minus 5. So this is gonna be x squared. We try to get the answer in one step. So you have to do some mental arithmetic. Negative 5x and 3x together, you want to get negative 2x. And 3 times negative 15, negative 5 to get negative 15. Yeah, we won't be able to do this one in one step because we will do this kind of computation so many times throughout the high school math, high school years. But see, x plus 3 squared minus 5. So first of all, let's expand this one using the formula, which is a plus b squared is equal to a squared plus 2ab plus b squared. So it's going to be x squared plus 6x plus 9. And you subtract 5. Combine like terms, you're going to get x squared plus 6x plus 4. Part D, minus x plus 1 squared plus 3. So first of all, let's expand this square. Don't forget the negative here. So it's going to be x squared plus 2x plus 1 multiplied by negative 1 plus 3. Removing the parentheses, you want to get negative x squared, negative 2x, negative 1 plus 3. That's going to give us plus 2. Okay, number 2, factor. So problem factor means you want to write the expression in the product form. So this is not the chapter 8 material, but it's like a chapter 7 material. So x squared minus 3x minus 10. You are trying to find the two integers whose product is negative 10, product is negative 10, and the sum is equal to negative 3. And you, after thinking for some cases, you're gonna get negative 5 and positive 2. So this is gonna be x minus 5 times x plus 2. Okay. When you are not too sure, try to expand this one mentally to retrieve the original expression for checking. Okay, so the product is negative 12, sum is 1, so it's going to be 4, 3. It's going to be x plus 4 and x minus 3. Okay, sum is positive 1 and the product is negative 12. Next one is a bit harder because the leading coefficient of this quadratic expression is not equal to 1. So if we try to follow the American way, first of all, you are going to find 3 times negative 2, which is negative 6. So we want to find the two numbers whose product is negative 6 and the sum is negative 5. So it's going to be negative 6 and positive 1. So break this one into two numbers, negative 6 and positive 1. The order could be opposite, doesn't matter. Now, look at the first two terms and look at the latter two terms. You can find the common terms. So take out the common factor. First two terms gonna be 3x times x minus 2. And the next two have 1 times x minus 2. And use distribution, which is ax plus bx is equal to a plus b times x. In this case, x means x minus 2. So it is 3x plus 1 times x minus 2. So here it's 1 times this, okay? In the Japanese way, it's gonna be using tasukigake. So you try to come up with two numbers whose product is 3, which is you only have 1, 3. And the two numbers whose product is 2, it's going to be 1, 2. That's the whole case. And you are going to do the tasukigake, which is when you cross multiplying and take a sum to try to get negative 5. So in this case, 3 times 2 gives us 6. 1 times 1 gives us 1. And because the product is not actually equal to 2, but it's negative 2, one of the number must be negative. So in this case, we want to make this number negative. So the sum becomes negative 5. So from this, the answer is 3x plus 1 and 1x minus 2. So yeah, either way is fine. Just use methods that you feel more comfortable with. Part D. 24x squared minus 72x minus 96. Now this one is don't try to do tasukigake because that number is have so many possible ways to factor it. So first things you should look at is like look for common factors. So all of 24, 72, and 96 are multiple 24. So first of all, we just remove 24 out. Then you can find whether this is factorable or not. Okay. Number 3, complete the square. Well, complete the square means when you have ax squared plus bx plus c, the quadratic expression can be written as this way, where x is only in one place and you have a square here. So here's how to do. To complete the square, what you are going to do is you are going to take half of the number attaching to x, which is negative 2. And you are going to add the square of negative 2 and subtract the same number. Okay, so you add 4 and subtract 4 at the same time. If you do this way, then you will see this part gonna be into squared form like this. Okay. So part B is the same. The negative term at the end doesn't affect the completing square process. So again, by looking at this part, you are going to add 4 and subtract 4. Okay, it doesn't change the expression. So this will become x minus 2 squared, and this part gonna be combined to get negative 14. Part C is a bit harder because this number is odd, but the idea is the same. What you're going to do is half of this number squared. You add and subtract that number. Now this part will become x plus 5 over 2 squared. Okay, and combine here, you will get negative 1/4. Okay, if you're getting comfortable with the process, then you can go from here to here in one step. You can do this in one step. Part D, 2x squared plus 7x minus 1. When you have the leading coefficient different from 1 in front of x squared, then let's factor out 2 first. So you want to get this. Negative 1, you can keep it outside because it doesn't affect the process of completing the square. Now do the same thing. Look at this number. Half of that number will be used. Half of that number will be used. So that's going to be 4 over 7 over 4. And you want to use the square of that number. This part will become x plus 7 over 4 squared. And remove the one of the outer parentheses. You want to get this. And combine these terms to make it to the complete square form. Okay. Now, number 4, 5, 6 is about solving for x, solving quadratic equations. The quadratic expression has 3 forms. One is a standard form. Another one is a factored form like this. And another one is a squared form like this. Okay. And problem 4 is solving a quadratic equation when equation is expressed in factored form. Part 5 is solving quadratic equation if the equation is given in the squared form. And problem 6 is solving quadratic equation when the expression is given in the standard form. So let's see how we are going to solve each case. Number 4. X minus 3 times x plus 4 is equal to 0. In such case, when the product of two numbers is equal to 0, then we know one of them, at least one of them must be 0. So we can say either x minus 3 is equal to 0 or x plus 4 is equal to 0. In the first case, x should be 3. Second case, x should be equal to -4. There are no other solutions because if x is neither 3 nor -4, then these two numbers are positives or negatives whose product cannot equal to 0. Okay, part B, x times x minus 1 is equal to 0. So again, this is the product of two numbers is equal to 0. So either x is equal to 0 or x minus 1 is equal to 0. This one simplifies to x is equal to 1. Part C, 3x plus 5 times 5x minus 1. Again, it's a product of two numbers is equal to 0. So either 3x plus 5 is equal to 0 or 5x minus 1 is equal to 0. Solving these equations, you get x is equal to -5/3 or x is equal to 1/5. Part D is actually not a quadratic expression, it's a cubic expression because you have a product of 3 x's, but the idea is the same. So when you have a product of 3 numbers, something times something times something is equal to 0, then at least one of them is equal to 0. So either x minus 2 is equal to 0, or x plus 4 is equal to 0, or x minus 1 is equal to 0. So x must be equal to 2, or x is equal to -4, or x is equal to 1. Okay, number 5. Part A, x squared is equal to 10. Okay, now we are going to solve the quadratic equation if the expression is given in the squared form. Key idea is this. When x squared is equal to 10, x is a plus or minus square root of 10. So the key idea is when you have like x squared is equal to some number, x is plus or minus square root of that number, given k is greater than or equal to 0. Okay. So b is x minus 3 squared is equal to 10. So look at the expression. X is in here only. To solve this one, first of all, remove the square. So some number square is 10. So inside the square must be a square root of 10s. And adding 3 to the both sides of the equation, you will get the solution. Okay. Part C. 2x plus 1 square minus 8 is equal to 0. Okay, so this is a squared form. X is only in this place. So move everything to the other side of the equation, one at a time. So the outermost number is 8. So add 8 to the both sides of the equation, you're gonna get this. Now, some number square is equal to 8. So that some number is equal to square roots of 8. Add 1 to the both sides of the equation. No. Subtract 1 to the both sides of the equation and divide it by 2. Okay. Square root of 8, I recommend you to write down in the form that the inside the radical is smaller number, smaller integers. So square root of 8 is same thing as square root of 2 times 4, which is square root of 2 times square root of 4, which is square root of 2 times 2. Okay. Okay, part D. X plus 5 squared plus 6 is equal to 0. Now this is equal to, so again, x is here. So first of all, move 6 to the other side. So x plus 5 squared is equal to -6. So x plus 5 is equal to plus minus of square root of negative 6. And this, since this is a non-real number, this equation has no real solutions. So no real solutions. Yeah, you can see that the square of any number is non-negative. So looking at this expression, you can see there is no real solutions. Okay, number 6. Part A. X squared minus 2x minus 3 is equal to 0. So when the quadratic equation is given in like X standard form, one thing you should consider is whether this is factorable or you can complete the square. And in this case, you can factor it. So if you can factor it, then you can obtain the answer immediately like this. Or you can complete the square like this. Half of that is -1. So it's gonna be like this. Then you can solve in this way. So bring 4 to the other side, take a square root, and add 1. So that's gonna be 3 or -1. Sometimes factoring is impossible, and the complete the square takes too much time. In such a case, you will use the quadratic formula. So there is a formula for finding the solution to the quadratic equation in the standard form. The answer is -b plus minus square root of b squared minus 4ac over 2a. A very lengthy formula, but we will use this one throughout the high school math courses. So you better memorize this one. Memorize. Okay. So for example, in this case, a is equal to 1, b is equal to -2, c is equal to -3. So using the formula, it's going to be 2, -2 plus minus square root of, looking at this number, squared, minus 4ac, 4 times 1 times -3, so it's going to be 12. So that's going to be square root of 16. So that's going to give us 3 when added, -1 when 4 is subtracted. Okay, part B. So this is something that you cannot factor. You cannot find two integers whose product is 5 and the sum is 3. So this is a better example to apply the quadratic formula. 2a -b plus minus b squared minus, looking at this one, so it's going to be positive 4ac. So it's going to be 20. So it's going to be -3 plus minus square root of 29. And because 29 is a prime number, you cannot simplify this. So you can stop at here. Part C. 2x squared minus x minus 28 is equal to 0. Again, if you can factor it, do it. That's faster. If you do not see this is easily factorable, then apply the quadratic formula. 2a -b plus minus b squared minus plus 4ac, which is 8 times 28, which is 224. So it's going to be square root of 225. Now you have to try to simplify it. Okay, and the square root of 225 is actually 15. So this is 1 plus minus 15 over 4. And if it is added, it's going to be 4. And if it is subtracted, it's going to be -14 over 4 or -7 over 2. Now, because the answer doesn't involve any radical signs, that kind of telling us that the original expression was factorable. And the factored form should have 4 and 2x plus 7. Okay, so if you factor it, you can do like this way. Okay, yeah, in fact, when you do like this, you see, oh, this is factorable. Okay, part D. 1/2 x squared plus 1/3 x minus 1/5 is equal to 0. Again, this is a quadratic equation in the standard form, so you can apply the quadratic formula. However, applying the formula to these fractions is kind of tedious. So one way to do is multiply both sides of the expression by some number to make it to integers. For example, let's multiply it by 6. So it's going to be like 3x squared plus 2x minus 6/5 is equal to 0. Then apply the formula. So it's going to be 2a minus b plus minus square root of 4 minus plus 4 times this times this. So it's going to be what? 4 times 3, 12, 72/5. Okay, so that's going to be 92/5/6. And that is equal to, let's multiply top and bottom by square root of 5. Okay, and let's multiply top and bottom by square root of 5 again. So it's going to be 30 multiply this times this, so it's going to be -10 plus minus. This is 92 is equal to 4 times 23, so it's going to be 2 times square root of 23 times square root of 5. So it's kind of complicated, but the answer is going to be, after dividing top and bottom by 2, it's going to be 15 divided by 2 divided by 2. The answer is going to be -5 plus minus square root of 115/15. Yeah, kind of complicated, right? Well, that was kind of bad. So let's try to do it in a different way. So let's multiply this one by 2. And I'm going to complete the squares. So take a half of that number and subtract the square of that number. That's completing square. Okay, so that's going to give us, oops. So these are, after bringing to the other side of the equation, it's going to be 4518 plus 523. So the answer is x is equal to plus minus square root of 23/45 minus 1/3. And after simplifying the radicals, it's going to be, first of all, 1/3 going to be came out because this is 9 times 5. And rationalize the denominator, it's going to be 15 and square root of 115. So we get the same conclusion, but computation is still kind of messy. Yeah. So that's complete explanation for the first 6 problems. In the next one, I'm going to explain number 7 through 12.